for lesson 2.4, modeling with quadratics. So story problems, real life problems, whatever you want to call them, problem solving with quadratics, which would be those parabola-shaped graphs. So here we go. A small independent motion picture company determines the profit P for producing N DVDs of a recent release is P equals negative 0.02 N squared plus 3.40 N minus 16. And that P is going to be in thousands of dollars and N is going to be in thousands of units. So a little bit of a dated problem here. We don't really do DVDs much anymore. But how many DVDs should the company produce to maximize the profit? Right? So maximize tells us we're looking for maximum profit. So the best way to do this would just be to graph it. My first instinct on this one is probably going to be to go to Desmos, seeing those decimal values. Desmos is probably going to be our go-to, right? So I'm going to type that in. Kind of hard for me to get both of them on the screen at the same time, but y equals negative 0.02. 0.002. No. So hard for me to get both of those on there at the same time, but we get y equals, we're going to go negative 0.02 x squared plus 3.40x minus 16. Right? I know they used P and N, but for this to work on Desmos and on your TIs, we got to change it to y equals on the left side, x on the right side. Right? So I am going to see if I can see some of the information that I need. What's my question again? It says, how many DVDs should the company produce to should they produce to get maximum profit, and then what will that profit be? Right, so let's zoom out on the graph. Right, I need maximum profit. My purple line is the profit. So if I tap here, I see that I have a maximum right there at 85. So how many DVDs should be produced for maximum profit? Well, it's not just 85, right? It's 85 in thousands, right? So 85,000. So 85,000s would look like that. They should produce 85,000 DVDs. And then for that Y value, right, I see 128.5. So 128.5, and they said that that is in thousands of dollars, right? So I would really need to multiply that answer by 1,000, right? So I'm going to shift that decimal 3 places to the left. Right, 1, 2, 3. So they're not making much money on that. 128 times 1,000, 128,000. So $128,500. Looking at our second example, we're asked to do some graphing, which the following equations represents the path of a donut hole being thrown by Johnny, where x represents the time and seconds that the donut hole is in the air, and y represents the feet in height of the donut hole. Right, so we have negative x squared plus 4x minus 2. The graph of the equation graph that equation, show at least 3 points. At what time does the donut reach its maximum height? And what is the maximum height of the donut? And when will that donut then hit the ground? Again, I feel like this is a great Desmos problem. So let's get Desmos up on our screen. So we have that y equals negative x squared plus 4x minus 2. I'm going to have to zoom back in on that. Right, so they asked us 4 questions. They asked us to graph it, showing at least 3 points. And I see some points right here. I see this initial point of 0, negative 2, which doesn't make a whole lot of sense in terms of real life. I see my vertex here at 2, 2. So that's going to answer questions B and C. When does it reach its max height, and what is that maximum height? And then approximately when will that donut hole hit the ground? Right? So if that black line is the height of the donut hole, starting at negative 2 doesn't make any sense. Johnny was below ground launching a donut hole out of a foxhole, which doesn't make sense at all. Right? But this point right here is when it falls back to the ground. So at about 3.4 seconds, we could estimate it at 3.5 seconds. But let's start answering some of our questions here. Right? I know that the donut hole reaches its maximum height at 2 seconds. And it has a maximum height of 2 feet. Right? So I can graph that here, and I have that initial point here, and I know it hits the donut. The donut hits the ground at about 3.4 seconds. I could estimate that and use that as my third point. Right, but there we go. We see it reaches its max height at 2 seconds, and it is 2 feet off the ground. So that should get you set to do lesson 2.4, some real life problems or real life situations using quadratics.